finish for today the soil one, this one here. If you did not finish the tests, don't worry about it. We're just going to move on. We had the experience. That's what all needed to happen. Does that make sense? The bottom part here, I apologize for how long it took me. I was busy during Liberty Time and I didn't get it all up right at the beginning of Liberty Time. But the information that you need from the 2 handbooks has now been put up on Canvas. So if you don't have that part done, you now have access to it. So you can find those. I think I labeled it like soil handbook analysis question answers or something like that. So that's up there. And then the video here, you just watch that quick video. And I think I linked to that on Canvas. I should have if I didn't. And then answer those questions, okay? If you didn't get it done. Not right this moment, but get it done during your day today, tomorrow, whatever works for you. The sooner the better. That's all I'm really saying, okay? Today, we've got just a little bit of stuff that I need to do content-wise for you, and then the rest of the time will be spent working, studying, getting ready for your test. Does that sound good? So you all have that blue sheet in front of you. The blue sheet is focused on how soils form. Does everybody have the blue sheet? It's right up here if you didn't get it already. This is a note sheet. So if you want to do it on separate paper, do it. That's fine. Either way works for me. Whatever you prefer.
I'm being a good teammate. Yeah.
I won't be here for tomorrow.
Okay. So you and I can chat maybe right after school and we can figure out the time to, or right after class.
Yeah, okay.
Yeah. Does that sound good? Yeah. Awesome. All right. So you may be wondering to yourself, or you may not. Either way, we're going to talk just quickly about how soil forms. Soil is a resource that can be renewed, that develops and changes over time. Okay, so we're going to talk just for a couple of minutes about how it forms. That's our goal for the day today. How does it form? Well, they made this fabulous mnemonic device, CLORPT, because that makes sense. I don't know. I didn't make that up. That somebody else did. But you'll see down the side of your notes that it says CLORPT. So each of these things is going to stand for something, and so then you can write down the information. Does that make sense? All right. We've talked about the fact that everywhere soil is different, right? Different places have different soil. And the things that it's dependent on, the C and L actually go together. Are they together in your sheet or no? Okay, well, you can mash them together because they should be together. The C and the L stand for climate. The O is for organisms. The R is for relief. And we'll talk about what that means. It really means the landscape. The P is for the parent material. And T is for time. But if you can't remember that, you can just remember CLORPT, because that's cool too, right? It's one of those funny mnemonics that I'm not sure if it makes a lot of sense, but hopefully it helps. It'll come right back up here in just a second. So again, climate organisms, which involve the vegetation, the relief, which is the landscape or topography, the parent material, and the time. We're going to go through each one. I don't know. I didn't make it up. I think it's one of those things that's been around for a long time.
It's just weird that they use the C and the L.
I know. Maybe there's another. I don't have any good answer. If I tried to make something up, I would be totally just lying to you. Yeah. I will be honest, Beth, I wondered the same thing. Yeah. All right, here we go. Ready? Climate. Climate is the C and the L in CLORPT. Okay? Temperature and moisture influence the speed of the chemical reactions. Do you need to write all of this stuff down? No. But you could write temperature and moisture. Those are the things that matter. Okay? Temperature and moisture impact how fast soil is formed. As temperature increases, weathering increases, and therefore soil, how soil is formed, sorry. I don't remember what I just said. So temperature and moisture are the two things. As temperature goes up, the weathering happens more frequently, and so therefore soil is formed more frequently or more quickly. I'm going to give you another slide on the same thing. Soils develop fastest in warm, humid, or moist climates, and slowest in cold, arid climates. Okay? Soils develop fastest in warm and humid climates, and slowest in cold, arid climates. You can imagine from that the types of places that are going to have more frequent or faster soil development, right? Well, Iowa in the summer is pretty warm and humid, right? But Iowa in the winter, not so much. If you go to someplace like a rainforest, soil is going to develop really, really quickly. Whereas if you go somewhere that is dry and cold, so like to the Arctic, for example, or the Antarctic, okay, soil is going to develop very slowly. It still does develop, but it's very, very slow. How are we doing with the coal in CLORPT? What's that? Oh, I'm sorry. Is that better? Yep, you just got to let me know. Yeah, of course. Now it's going to be in Haley's way. Is that better? Everything good? I can move everything.
Yeah, you're good.
I can't move the desk. That I cannot do. This one does. This one is like, yeah. I mean, maybe you can, Haley. You've been lifting more than I have, I guess. I don't know. All right, here we go. Is that okay? We good? Let's keep it going. I mean, I don't know. I don't want to assume. Always dangerous. Organisms. That's the O in CLORPT. I love this picture. It's so cute. Oh, do you know what that is? A little mole? I think it's a mole.
It is a mole.
So, how do organisms affect soil development? Plant roots spread out, right? And they kind of break stuff up. Animals burrow and bacteria eat. Organisms speed up the breakdown of soil, okay, by their interaction with it. That's the key. Organisms help to break down soil. Breaking it down helps to make new stuff. I will also put this up on Canvas, so if you need access to it, you want to look at it again, it will be up there. A little bit more about organisms. Is that okay if I click or not quite yet? Okay. I just get excited. Trying to figure out if that mole is happy or not. What do you guys think? It's like, hey. One of my favorite books that my kids got when they were little was about a mole that got pooped, like somebody pooped on his head, and then he walks around trying to figure out who pooped on his head. It's a pretty hilarious book. The flies are the people that tell him who it is, because, you know, it's a good time. Anyway. Yeah, they're just really tiny. Because they live underground most of the time.
Where?
Right there. All right. Speaking of organisms, roots are powerful. If you live in an old neighborhood and there are lots of big old trees, you may see sidewalks or driveways that are cracked by roots, right? The root comes in and it breaks up. I mean, cement and concrete are really, really hard, so that's pretty impressive. Roots are powerful forces. They produce carbon dioxide, they mix with water, they form the acid that wears away rock. Again, you do not need to write all of this down. You need to know that roots can help break down soil. That's what you need to know, friends. And I'm not trying to discount all of the other information. I'm just trying to have you not stress about lots and lots of content. Okay? All right. We okay? We good? Ish. All right. CLORPT, right? R is next. R for relief. Relief means topography. Relief means landscape. Now we're talking about what the shape is of the area. Okay? That's what topography is, yeah. A topographic map is the one where you can like see, like it has the circles, so that you can like see the elevation change. Yeah. The shape of the land and the direction it faces make a difference in how much sunlight the soil gets, how much water the soil keeps. So keywords to write down here: shape of land, direction it faces, right? Again, you do not need to write down all of these words. Hit the highlights. Hey, you'll tell me if I'm in the way, right?
Huh?
You'll tell me if I'm in the way.
Oh, yeah.
Okay, I figured. I'm just moving over so that I'm out of the way for more people. Do you think that soil is able to form more easily on a steep slope or on a shallow slope? Shallow. Why? What's that? It gets more sunlight? What else happens to soil that's on a really steep slope? It's going to fall down. It's going to erode away, right? So you're not going to be able to develop better soil on a big steep slope. What's that? Well, water would run off too, but it's going to take some of the stuff with it, right? Erosion? Yeah. Speaking of those steep slopes, deeper soil tends to form at the bottom of a hill, excuse me, than at the top because gravity and water have moved the soil down, right? So down at the bottom of a steep slope, okay, in the valleys between mountains, you end up getting really, really good soil that's able to regenerate very, very quickly because it's stable and because all those nutrients keep coming down from the slopes on the sides. I'm going to keep cruising if that's okay. We good? Ish. These next couple slides you do not need to copy down. It's just more FYI. Things that you may see another time. Or if you like to, indoctrinate yourself with words that you want to know. Names of slope locations. The summit, you've probably heard that one before, right? Like the top of a hill. As you go down, there's that little kind of bump. That's called a shoulder. The back slope, the foot slope, the toe slope, the drainage way. Woo, lots of different things. It's one of the things, I feel like it's kind of nice for you to just know that those things have names, that they do exist. If you become a geoscientist, if you become a horticulturist, if you become a soil scientist, these things are going to matter a lot for you. If you become a civil engineer, these are going to matter a lot for you. But out in your normal daily life, you know what I'm saying? In addition, I think this is just kind of cool. I'm going to turn the lights off so you can see the color difference well. Different areas of the slope have different colors, which is kind of cool. The color tells us how the soil behaves. Soil drains well is going to be brightly colored. One that's wet and soggy turns to gray and black. It's kind of interesting. There's so much interesting stuff going on with soil. Just never know. All right. CL was what? Climate. O was? R was? And now we're at P, parent material. Oh, parent material. Just like you inheriting some of your characteristics from your parents, soil does the same thing. Aww. Soil inherits traits from the material from which it is formed. What does that mean? Well, we'll talk about it. I agree 100%. Again, we stole these from the soil science people, right? I don't think that they were thinking about that logistics. Yeah, maybe they expected bigger screens or just not having a bunch of stuff in the way. Can you read everything though? You okay? All right. Soil that forms in limestone is rich in calcium. You don't have to write this down, but I just kind of think about it. So limestone is one kind of rock, right? And it happens to be rich in calcium, so that means that the soil then gets some of that calcium. So that soil, if you were doing soil tests, and one of the soil tests was a calcium test, it would have a lot more calcium than other soils. Soil forming at the bottom of lakes are high in clay. Again, not a surprise, right? You've got that wet material. That's what's going to happen. Parent material, you remember we talked about the parent material when we were looking at the horizons, right? There are kind of three parts that you can break down parent material into. In that box, you mean? I don't think so. They're going to go through each one of them just a little bit, but I think it's one of those things where if we just kind of talk about it, appreciate it, it'll be okay. Okay. Transported materials, transported sediments. So water transports and deposits them. Wind transports. Gravity transports. Ice transports. All of this is known as what? What's the word that we've used for so many days, so many years? When we move sediment from one place to another, what's that called? It's not weathering. Weathering is the breaking down. Erosion. Erosion is the moving away, right? That's what this is. I'm going to keep clicking here because this is kind of like way deep. We're going to go into time. Last one. CLORPT. It wouldn't be CLORPT without the, right? It'd just be CLORPT. That's not quite as fun.
There's not even a word.
My reaction almost was like, you're not even a word, but that wouldn't be very nice, so I won't say that. You're an awesome person, though, Hannah. All right, here we go. Time. Older. Shh. Friends, we're almost there. Shh. Older soils differ from younger ones because they've had longer to develop. It's just like people, right? The key here, the thing that I want you to understand is the older the soil, the more horizons it has. Remember those horizons, those things in the soil profile, right? The more layers that it's had time to develop. Yep, the more time it's had, the more horizons there are. The more developed the horizons are. Okay. And by this, we're talking about it over like a long period of time. We're not talking about 20 years. We're talking about hundreds and thousands of years. In the northern U.S., that's where we are, soils tend to be younger because glaciers covered the surface during the last ice age. While there were glaciers covering it, no soils could form, right? In the southern U.S., there were no glaciers, and that means that the soils have been exposed for a longer time. Okay? Yeah.
What's like old soil? Like how long? Like
How old are we talking? That's a really good question. I mean,
that seems like a long time ago.
that is a long time ago. But if you think about it, like, so do you remember when we dug that hole in my yard, right? And I saw like all the way down, like, 48 inches down. That soil that was down there had not been disturbed for hundreds of years at least, right? So we're talking on the order of hundreds or thousands of years when we're talking about that. Now, when we're talking about the topsoil isn't going to be old because it's going to have been weathered. So there's kind of like old and new, and just because one part's old doesn't mean the whole thing is. Does that make sense? Yeah, it's a good question though. I like that. This last slide has a lot of words on it. You don't need to write them down, but I do want to share this with you. So again, this is a very general statement, right? Very general information, but every place and every kind of location in terms of the CLORPT, right? All of those pieces as they go together give us a new story about soil. So I'm going to read this to you because it's really, really small. I know that's what I just told you. It's really small, so I'm going to read it to you, but it's interesting. So this comes from, I think it was the soil people in Iowa studying the soil that we have in Iowa. And as we've said, the soil in Iowa is different from anywhere else in the U.S., anywhere else in the world, really. Okay? This soil that we have, that we kind of identify with, occurs in 28 of Iowa's counties. Do you know how many counties we have in Iowa? 99 counties. Ding, 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 ding. Yes, that's one of those things I want you guys to know. You're Iowans. You should know that. 99 counties, as well as in Minnesota, Wisconsin, Illinois, and Indiana. It was first identified in 1917, and the Tamus soil is identified on a series on more than 933,000 acres. It says that it's formed in wind-blown, dominantly silt-sized particles known as loess, okay, and in more than 60 inches in depth and underlying earth material. It has a topsoil and subsoil with textures of silty clay loam. You guys have heard those words, right? Silty clay loam. You can find those on your triangle, okay? So that's what most of it is. I just lost my place. Where'd it go? There it is. Dominated by silt-sized particles and generally less than 5% of sand-sized particles. There is a very, very specific, I would almost argue, fingerprint, right, that describes the soil that we have in Iowa. All of these pieces make it what it is and make it as rich and great for growing things as it is. Okay? I was going to say one other thing. Did I lose it? I did lose it. That's okay. All right. Questions that you have about CLORPT? Okay. Right now, you have got 20 minutes to study, to review, to go through things. Okay?